Okay guys and girls, I have a problem. I don't know what that angle is. Although I think that says 65/15, but I don't believe that that's correct. Okay, so I put a straight line into it using a level, which really doesn't give you anything. What I ended up doing was going up using this plumb bolt that I made up, just a piece of string, pulling down, and this speed square, right? And I got my angle. So on the pivoting, you've got a pivoting point there. You pop it on to there like that, on the pivoting point, and try not to let it move. You come down the bottom, pivoting point, as it stops. It ends up being about, if you read the bottom scale, that's in degrees. Okay, so it is 10 degrees on that. So that's what I did, took that 10 degrees from there and had a practice. So I got this piece of scrap piece of wood to test it. Now, most people online will show you how to get your degrees, but won't show you how to transpose those onto the other sheet. There is a guy there, I'll try and list him. He explains these speed squares a lot better than me. I'm only in Australia and we don't usually use them, but I saw someone in America using one and I thought, I've got to have one. Alright, so I bought that. I bought that on eBay and I got it for about $30. It's cheaper than buying it from Bunnings in Australia. So it's aluminium with white numbers on it and it has conversions on the back. Alright, it's all in inches, mostly in inches, anyway. Actually there's metric down the side here, metric on the other side on this one. So, but some of it's in inches. So this stuff here is all in inches. So rise, so if you get a 2, let's say we've got a 6 for our rise, so this is the rise here, going up is your 6. Which is the outside line, and on the inside line, say we got a 12, so we'll have a run at the flat end of 12. So you've got height over length, or in other words, tangent. So it's maths. When you remember tangents at school, you probably thought, oh my God, I'm going to never ever need these. Well, tangents actually come in, it's a Greek word for height over run. I think it's rise over run, but anyway, I'm calling it height, and that is my length in this case. That's how we're taught it here in Australia. Now, what I did was I got my straight edge. I didn't use this as the straight edge. I could have used this as the straight edge. So I could have gone and put that in there and then run it and then lined it up there. Once I got that straight line, all I had to do was I had to come off, get the pivot point and go to off that line. I had to go use the pivot point and go up to 10 degrees. So in this case I flipped it. I think I flipped it. Yeah, I did flip it, and I went off the point and I went up to 10 degrees, which was around about there, I believe. On this one, 10 degrees is there. So it's 5, 10, 15. So I put it on to 10, drew that line in, cut myself a spare board, and I measured that up against the wall. I'll give you a quick show, and it actually lines up real well. So that board there is square, that's up against that, and the run goes all the way down at 10 mils all the way down. So that's how I got my square. Sorry about the piece of tin, I still need to stick that back up. Okay, so here we got our 6, our 12, and up here is 13 point round about 4. So I measured it and calculated it out. So that is the length from the height from there to there, and the width from there to there, or as they call it, the rise over the run. Okay, and that's how you work out, and that's your 90 degrees in that corner, old maths. So if this is 10 degrees, that'll be 80 degrees. And so that has to make up that there. So I'm thinking that'd be 80 and that'd be 10 on there for the maths. So yeah, just a quickie for all the people that subscribe to me. And by the way, more to come on that. That is coming up very soon, and everyone's going to be happy that the way I'm going about this. Everyone's going to be going, especially you, Ben. I know what caused that, and that'll be in a soon to be revealed.